23% of your dashboard requests are returning blank data panels. No error in Sentry, no 5xx in logs, just empty arrays. The root cause? A silent try-catch in a server component. In Next.js 16, the reset function in error.tsx only re-renders the boundaries children. If the error is caused by a server component data fetch, reset will re-execute the same fetch, likely causing the same error. To avoid infinite loops, combine reset with a retry count or use window location reload for non-recoverable errors. The article mentions that error.tsx does not catch server component errors. Here's a concrete pattern. Wrap your server component's async data fetch in a try-catch that logs the error and returns a fallback UI. This prevents silent failures and provides a user-friendly message. When logging errors in server components, avoid using console error alone in production. Log aggregation tools often parse structured JSON. Use console error, JSON, stringify, level, error, message error, name, message, stack to ensure logs are queryable. Also, never log sensitive data like user tokens or database credentials. Let's break down advanced error handling and logging in Next.js 16 applications, how it works, and the exact mistake behind that failure. Advanced error handling in Next.js 16 is the practice of catching and surfacing errors that occur inside server components before they silently degrade the user experience. Server components execute on the server and stream serialized React tree data to the client. Any thrown error during that execution is caught by the RSC boundary, but unless you explicitly wrap the component in an error boundary, the error is swallowed and the client receives an empty or broken subtree. This is fundamentally different from client-side error handling because the error never reaches the browser's console or window owner. Next.js 16 uses a nested error boundary system that maps to your root segment structure. Each root segment can define its own error, TSX, which catches errors from all children server components, client components, and data fetching within that segment. The global-error.tsx file at the app root catches errors that escape all nested boundaries. It must be a client component and defines the entire application's last resort fallback. Here's a practical error boundary component for a dashboard root segment. It logs the error to your monitoring service with root context and the error's digest, then shows a user-friendly fallback with a retry button. The reset function re-renders the boundaries children, allowing users to recover from transient failures. Production logging in Next.js requires a unified approach across server components, root handlers, server actions, and client components. Server-side logging should emit structured JSON with correlation IDs, request context, and severity levels. The correlation ID pattern is non-negotiable for production debugging. Generate a unique ID per request in middleware, attach it to the request context via async local storage or headers, and include it in every log entry and error report. This structured logger class creates a logger instance per request with a correlation ID from the request headers. Each log entry is a JSON object with level, message, context, and error details. This makes logs queryable in aggregation tools like Datadog or CloudWatch. Without correlation IDs, debugging a production error requires guessing which log entries relate to the failing request. Server actions in Next.js 16 execute server-side but are invoked from client components. This creates a unique error handling challenge. Errors must be communicated back to the client without exposing internal implementation details. Never throw raw error objects from server actions to the client. Instead, return structured error response objects with typed error codes and user-safe messages. This server action uses Zod to validate input at the boundary, rejecting malformed data before it reaches business logic. On success, it returns a typed success response. On failure, it logs the full exception server-side and returns a structured error with a code and user-safe message. The client can then render appropriate UI based on the error code, field-level validation errors, login redirects, or generic fallbacks. Client-side errors in Next.js 16 require different instrumentation than server-side errors. Install a global error handler for uncaught exceptions and unhandled promise rejections in a top-level client component or layout. This catches errors that escape React's error boundary system. Hydration mismatches are a common source of client-side errors. Log them with the actual versus expected content to identify the root cause. This error instrumentation component sets up global event listeners for uncaught exceptions and unhandled promise rejections. It captures these errors with source tags and sends them to your monitoring service. This catches what React error boundaries miss, errors that escape the component tree entirely. Production error handling is incomplete without monitoring and alerting. Integrate Sentry, Datadog, or a similar APM tool using the official Next.js integration. Configure alerting rules based on error rate thresholds over rolling windows. A single 500 error is noise, but a 5% error rate on a specific endpoint is an incident. Implement error grouping to prevent alert storms during cascading failures. This Sentry initialization configures sampling rates for traces and replays, filters out known non-critical errors like browser extension errors, and redacts sensitive data from breadcrumbs. The before-send hook allows you to filter and sanitize events before they reach Sentry, reducing noise and protecting user privacy. Error handling is ultimately about user experience. Implement tiered fallback strategies based on error severity. For transient errors like network timeouts, show a retry button with exponential backoff. For data errors like missing resources, show contextual guidance. For catastrophic errors, show a static fallback page with a support link. Always show an error digest or ID so support teams can correlate user reports with monitoring data. This graceful error component implements tiered fallbacks. For transient errors, it shows a retry button with exponential backoff and a maximum retry count. For critical errors, it shows the error digest, a feedback text area, a retry button, and a support link. This gives users a path forward instead of just a problem statement. Custom error classes that extend error preserve instanceof checks and stack traces. Define a status code property for HTTP responses and a context object for serialization. This pattern survives minification because class names are preserved. In Next.js, these custom errors become powerful when paired with error boundaries. A database connection error can trigger a retry mechanism, while a validation error returns immediately to the client. Your 500.tsx file in the app directory is your last line of defense when everything else fails. It needs three things: a recovery action, a correlation ID, and suppression of sensitive data. Use instanceof checks to route to different UI treatments. A rate limit error gets a cooldown timer, a database connection error gets a retry button. This 500.tsx page generates a correlation ID, logs the error server-side, and uses instanceof checks to render targeted recovery actions. For database connection error, it shows a retry button, for rate limit error a cooldown message, and for other errors a reload button. The correlation ID is displayed so users can provide it to support. This is the same issue we highlighted at the start. Here's exactly why that happened. A server component was silently catching a Prisma connection pool timeout error inside an inline try catch. The catch block returned an empty array instead of throwing or logging. The error boundary never triggered because no exception propagated. The connection pool exhaustion was caused by a missing connection release in a background job. Users saw blank data panels with no error indication. An inline try-catch in a server component swallowed a Prisma connection pool timeout, returning empty arrays instead of throwing or logging. Removing the try-catch lets errors propagate to the nearest error, TSX boundary. The fix was to remove inline try-catch blocks from server components and let errors propagate to the nearest error, TSX boundary. We added structured logging with correlation IDs in every data fetching layer and implemented connection pool monitoring with alerting at 80% utilization. Now, when a Prisma timeout occurs, the error propagates to the error boundary, which logs it and renders a fallback UI. The key change was removing the silent catch and letting the boundary handle the error. This inline try catch silently returns an empty state when fetch data throws. No error is logged, no boundary triggered. Users see incomplete pages with no feedback. Instead, let the error propagate to the error.tsx boundary, which will log it and render a fallback UI. Throwing from a server action causes Next.js to return a generic 500 response with no structured error data. The client cannot distinguish between validation errors, authorization errors, and internal failures. Always return structured error response, objects with typed codes and user-safe messages. Throwing strings gets mangled by minifiers, loses stack traces, and provides zero context. Always extend the error class. Never throw strings or plain objects. Your error type is your first line of defense. Without global-error.tsx, a root-level crash renders a blank white page with no error message, no retry button, and no monitoring capture. Always create app/global-error.tsx as a client component with error logging, a user-friendly message, and a retry button that calls window location reload. Here are quick diagnostic commands for production error triage. Check server logs for unhandled promise rejections using kubectl logs. Verify error.tsx files exist in the correct directories. Test Sentry DSN connectivity with curl. Implement correlation ID middleware and verify its passing headers. Let's run through some common interview questions. How do error boundaries in Next.js 16 differ from standard React error boundaries? Next.js 16 error boundaries are root segment scoped. Each root segment can define an error.tsx that catches errors from all children. Server component errors propagate through the RSC tree to the nearest error.tsx, while client component errors follow standard React boundary rules. Next.js also provides global-error.tsx for root-level catches and a reset prop for retry functionality. What is the correlation ID pattern, and why is it critical for production error handling? Correlation ID is a unique identifier generated per request in middleware and threaded through every log entry, error report, and downstream service call. It enables tracing a single user's request across all server-side operations. Without correlation IDs, debugging production errors requires guessing which log entries relate to the failing request. Why should you never throw raw error objects from server actions to the client? Throwing from a server action causes Next.js to return a generic 500 response with no structured error data. The client cannot distinguish between validation errors, authorization errors, and internal failures. Instead, return structured error response, objects with typed error codes, and user-safe messages. And a few frequently asked questions. Does error.tsx need to be a client component? Yes, error.tsx must be a client component because it uses React state and lifecycle methods, the reset function. Add use client at the top. How do I handle errors in server components without swallowing them? Let the error propagate to the nearest error.tsx boundary. Do not wrap data fetching in inline try-catch blocks that return empty arrays or null. If you need to log before the boundary catches, use a try-catch that logs and then rethrows. What is the recommended traces sample rate for Sentry in production? Use 0.1, 10% for traces sample rate in production to balance cost and visibility. Set replays on error sample rate to 1 and replays session sample rate to 0.01005. Let's recap the key takeaways. Next.js 16 error boundaries are root segment scoped. Structured logging with correlation IDs is foundation of observability. Server actions must return structured error responses. Alert on error rate thresholds over rolling windows. Ready to go deeper? Up next, building an AI SaaS from scratch with Next.js 16, then building multi-agent AI systems with Next.js and LangGraph, then getting started with Next.js 16, installation and project structure and pages and layouts in Next.js, file-based routing explained. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.